Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 7.4, choose the best method for solving. Now that you know 3 different ways to solve a system of equations, remember that was all from first semester, you can choose which method makes more sense to use given the way the problem is set up. Examples: write the method that makes the most sense to use for each problem and then solve. So what we're going to do first is we're going to go through each one of these 4 problems and we're going to talk about which method is the best way to solve. You can either graph them, you can use substitution, or you can use elimination. So problem number 1, I have y equals 2x minus 3 and I have 3x minus y equals 5. In my opinion, the best way to go ahead and solve this is by substitution. The reason for that is that we already have y by itself. Since we already have y by itself, it's just as easy to take the 2x minus 3, plug that in for y, in order to solve by substitution. Problem number 2, I have 5x minus 2y equals 7 and 3x minus 2y equals 15. In this case, I am just going to give you guys a heads up. On a worksheet like this, I'm never going to graph it. Okay, it's either going to be substitution or elimination. Okay, since I do not have x or y by itself, and it does not look to be very easy to get x or y by itself, I'm going to go ahead and use elimination for this problem. The reason why is it will be easy to make the coefficients of y opposites. We'll talk about exactly how we do elimination again here in 1 second. Okay. On to example 3, I have 4x plus y equals negative 2. I have negative 2x minus 3y equals 1. In this situation, it would be easy to get y by itself in that first equation, or it would be easy to make the coefficients of x opposite. So really, substitution or elimination would be just as easy as one another. I personally like elimination better. It gets rid of one of my variables right away without me having to plug anything in. So I'm going to use elimination here, though you would not be wrong if you said substitution on that problem, because it would be just as easy to get y by itself. So it is easy to get the coefficients of x to be opposites. Okay? On to the last problem, I have 4x plus 9y equals 24. I have y equals negative 1 over 3x plus 2. Again, I have y by itself, so I'm going to use substitution. The reason why is y is already by itself. All right, now that we've gone through and figured out which method makes the most sense for each problem, let's go ahead and solve the problems. Okay? The first problem is substitution. Remember, what we're going to do is we're going to take this 2x minus 3, plug it in for that y, because y equals 2x minus 3. So when I do substitution, I go ahead and start writing out the problem exactly the way it looks. When I get to the variable I want to substitute for, I'm going to put a set of parentheses, plug in what equals that variable, and then I'm going to go ahead and work through the problem from here. I have a negative 1 that I need to distribute, so I'd have 3x minus 2x plus 3 equals 5. Remember, when I distribute a negative, it just changes the signs. So 3x minus 2x is positive x, plus 3 equals 5. In order to solve for x, I would subtract 3, so x would equal 2. Now that I have what x equals, I can plug 2 in for x in one of my two equations. I'm going to choose the top equation because y is already by itself. So y would equal, again, just like I did to substitute originally, I'm going to write the problem exactly the way it looks until I come to the variable I want to substitute for, which is that x. So it's 2 times 2 minus 3. So y equals 4 minus 3. Y equals 1. I need to write my answer as an ordered pair, so 2 comma 1, and we are finished. All right. Problem number 2, elimination. Remember, with elimination, what I'm going to do is really add my two equations together. When I add them together, I want to make a situation where one of my two variables disappears. In order to do that, I need to have the coefficients of one of my two variables to be opposite. So what I'm going to do in order to make that happen, as you can see, I have a negative 2y and a negative 2y. What I need to do is make one of those two y's positive. So I'm going to multiply the top equation by negative 1. When I multiply by negative 1 times 5x is negative 5x. Negative 1 times negative 2y is positive 2y. Negative 1 times 7 is negative 7. Okay. From here, I'm going to add the 3x minus 2y equals 15 and my new equation I just made. So 3x minus 5x would be negative 2x. Negative 2y plus 2y would just cancel. 15 minus 7 would get me 8. Divide by negative 2. X would equal negative 4. Now that I've taken care of all that, I do not want to plug my negative 4 into the equation I made. I want to plug it back into one of the two original equations. I'm going to choose the 3x minus 2y because they are smaller numbers. So I'd have 3. Remember, x is the variable I'm going to plug in for. So start writing your equation until you run into an x, which is what I do right away. So it's 3 times negative 4 minus 2y equals 15. 3 times negative 4 is negative 12, minus 2y equals 15. Add 12 to both sides. Negative 2y equals 27. Go ahead and divide by negative 2. So y equals negative 27 over 2. Again, I need to write my answers as an ordered pair. So negative 4, negative 27 over 2, and I am done. A reminder, please do not write that as a decimal. Please do not write that as a mixed fraction. Leave it as an improper fraction. Okay? The higher level you go in math, the more often you're going to use improper fractions, so you might as well get used to them now. Now, problem number 3. Again, remember, you could have used substitution or you can use elimination. Again, I just think it's extremely easy to make the coefficients of x be opposites. In order to do that, I have a 4x and I have a negative 2x. I need them to be opposites, so I would need either both of them to, or one of them to be a positive 2x and one to be a negative 2x, or one to be a positive 4x and the other to be a negative 4x. Well, since I can't really divide by 2 all the way across on that top equation, I'm going to go ahead and multiply by 2 in my bottom equation. When I multiply 2 times negative 2x, I get negative 4x. 2 times negative 3y would be negative 6y. 2 times 1 would be positive 2. From here, I'm going to add this equation and this equation up. So 4x minus 4x would get me 0x. So those technically cancel. Then I have y minus negative 6, or y minus 6x, which would be negative 5y, equals negative 2 plus 2, which would get me 0. Divide by negative 5, y equals 0. Now, I need to take my 0, plug it in for one of the y's in one of my two equations. I think the top equation will be easier because I do not have to take my number for y, multiply it by anything. Y is already essentially by itself. So it would be 4x plus, make my parentheses where my variable is going to be, minus 2. The 0 goes in there, so I'm left with 4x equals negative 2. Divide by 4. x equals negative 1/2 when I simplify. So my ordered pair is negative 1/2, comma, 0. Remember your ordered pair, x always comes first. Finally, problem number 4, I'm going to use substitution because my y is by itself. So I'm going to take this whole piece and plug it in for that y. So I'm going to start writing my equation exactly the way it looks until I run into y. And I'm going to make a set of parentheses for negative 1 over 3x plus 2 is equal to 24. Finish writing the problem or the equation the way it looked originally. Take 9 times negative 1/3 x. Just take my 4x plus, bring it down. 9 times negative 1/3. That would mean I have 9 times negative 1, which is negative 9 over 3, which would actually get me a negative 3x. 9 times positive 2 would be positive 18 is equal to 24. 4x minus 3x would get me x plus 18 is equal to 24. Subtract 18. X equals 6. Now that I know what x equals, I can plug it back into one of my two original equations. I'm going to use the bottom equation because y is already by itself. So y equals negative 1 over 3. Just write the problem exactly the way it looks until you run into the variable, which is right now. So times 6 plus 2. 1/3 times 6, y would equal 1/3 of 6. A third of 6 is 2. The third was negative, so it would be negative 2 plus 2. So y equals 0. My ordered pair would be 6, comma 0. And I am done. So what the biggest thing was about this note sheet today is recognizing which one of my methods will be the easiest to solve the problem with. Usually you're going to use substitution or elimination. I hardly ever want to really graph them. That just takes so much work and gives you a large area of error. If you're going to use substitution, the times you're going to use substitution is when one of your variables is already by itself, or it would be extremely easy to get a variable by itself. The reason why you use elimination is because the coefficients of one of your variables are the coefficients of one of your variables are already opposite, or it would be extremely easy to get them to be opposite. Once you have done the initial step with either of those methods, then it's the same steps from that point on as far as solving for one variable, plugging that back into one of the equations. All right. Well, thank you very much for watching the video. Remember, if you have any questions, to come see me or ask me while you're in class. Otherwise, have a great day.